So in this video, we're going to go over some basic problems to reemphasize those points from our initial lecture in this chapter. In the first problem, we're told that we have a 100-pound box and it's sitting on a surface which has a coefficient of static friction with it of 0.4. And we're asked which of these three force orientations, denoted as PA, PB, or PC, would require the least amount of force to begin sliding. And what they're referring to there is the magnitude of those individual vectors. So if you look at this particular problem, if you were to draw a free body diagram, and we don't have to because it's a pretty easy problem, you can imagine you have a 100-pound block, and that has a weight applied at its center of gravity in the downward direction. And of course, we have a normal force at the point of interaction, which is going in the upward direction. Now, if the force applied either at this upper right corner of the box didn't have any vertical component, if it were purely horizontal like P sub A, in that case, the normal force would simply be equal to the weight of the box. However, in the case of PB and PC, we'll note that a portion or a component of the applied force actually goes in the downward direction. And what that's going to do is to increase the normal force. The normal force in that case would have to not only counterbalance the weight, but also counterbalance the Y component of this applied force. So when you think about what it means for that box to actually start sliding, remember that that means that the horizontal component of the applied force has to overcome the maximum static friction force. And the way that you compute the maximum static friction force is this coefficient of static friction, mu sub s, times the normal force. And so what is going to happen is, if our applied force has any component in the downward direction, that will increase the normal force, which will increase the maximum force of static friction, making us apply a larger force in order to go and get this thing moving, to kind of overcome that impending motion. So what happens is exactly what you would think would happen. Namely, if you just purely in the horizontal direction, you're going to have to apply less force in order to get this thing moving. So the answer is A, or P of A. In this case, we have a block. We're told that it is 10 pounds in weight. We're given the coefficient of static friction, 0.3, and given an applied force in the horizontal direction, we're asked to find the friction force between the block and the surface. So in terms of computing, knowing that this thing is not yet moving, that it's pending motion or less, we can draw a free body diagram. And what we notice is that in the downward direction, we would have the 10-pound force corresponding to the weight. In the upward direction, we would have a normal force that's equal and opposite to that. And in the horizontal direction, we have this 2-pound applied force to the right. And what must be counterbalancing that is a frictional force that's parallel to those two surfaces and is sensed or in the direction that's opposing the relative motion, so pulling back to the left. So if we look at what's going on here, what is the maximum static friction force? Well, if the normal force for this loading configuration is just going to be 10 pounds, and the way that I know that is the weight down is 10, so that means the normal force up must be 10 if there's no other vertical forces. And the maximum static friction force is that normal force, 10 pounds, times the coefficient of static friction, which is 3 pounds. So 3 pounds is the maximum frictional force could be applied. However, in this case, if the horizontal force is only 2 pounds, in order to keep this thing in equilibrium, the only frictional force that's required is 2 pounds. So the point of this question, the answer is C. Don't be confused and pick D. Just because D is mu sub s times n, remember that's the maximum frictional force, and that only occurs in the scenario when the applied force is actually equal to that. So if we're only applying 2 pounds of horizontal force and the maximum static friction force is greater than that, then the frictional force is just going to be equal and opposite to the applied force. So 2 pounds is that answer. In this question, we have a ladder kind of leaned up against the wall, kind of on the corner of this wall segment here, and we're asked to indicate the direction of the friction force on the ladder at B. So remember that frictional forces are always parallel to the surface of interactions. We have this point of the wall kind of interacting with the surface of the ladder, which is angled at the direction from A to B. So naturally, we can throw away answers A and B. A and B are in either the vertical or downward vertical direction, and those aren't going to be aligned parallel to the two surfaces at the point of interaction. So it has to be C or it has to be D. The question is, what is the sense or what is the direction? Well, if you ever lean something against a wall, you know that what happens is a portion of the weight actually acts along the, you can decompose the weight. The weight is always acting in the downward direction, but you can decompose it into a component that acts along the direction of the ladder. And that's what actually causes it to slide down, is its own weight. So weight, by definition, is going to tend to pull the ladder in the downward direction. So the force that the wall exerts on the ladder in order to counterbalance that is going to have to go in the opposite direction or in the upward direction. So the frictional force that the wall exerts on the ladder is C. in that case. So hopefully that gave you kind of a review of some of the key concepts of the first video, namely frictional force always acts parallel to the orientation of the two surfaces, the concept that the frictional force is not always equal to the maximum coefficient of static friction, and in addition, the idea that in order to actually cause a box to slip or slide, or any object for that matter, you have to exceed that maximum frictional force. So I will see you all in the next video.